Hello and welcome back to another video. Today we will be doing the homework due on October the 16th about Chapter 4, Forces 1.5. For the multiple choice, I can't really give you the answers because that'd be cheating, but you should keep in mind that the difference between mass and weight in that weight is relative to the gravity of the planet you are on, and also that the constant g is, in the context of these problems, going to be positive. And for the question about Newton's law of inertia, just think about what would happen in this situation in real life. Okay, so this homework will require a new formula that we haven't learned in class yet, which is that acceleration is equal to the net force over mass. So remember that the units for this equation are going to be that the force, the net force, is in newtons, or N, that the mass is in kilograms, or kg, and the acceleration is going to be in meters per second squared. So for the first problem with numbers, which is number 4 for me, that's about the force applied to a mass. So in this case, what you're going to want to do is use this formula over here and solve for force. So force is equal to mass times acceleration. So for me, I'm going to fill these in and say that that 1.4 times 3.9 is equal to 5.46. And then now that we know the force being applied here, we can apply it to the new mass. So we can say that acceleration equals 5.46 over the mass, which is 11.4, which gets me my answer of 0.48. Okay, now for question 5. So we take this initial equation, so A equals F net over M. So if this force is multiplied by 8.2, then in order for this equation to stay true, both sides have to be multiplied by that, which means that 8.2A equals 8.2F over M, which means that 8.2 is going to be the answer. So for question 7, you're going to want to find the acceleration of the dragster here. So acceleration is this here. It's going to be the speed it reaches. So 25.6 over 0.56, also equal to 45.7. And this is the average acceleration of the dragster, 45.7 meters per second squared. Then for part 2, now that we know this value, we can apply it to the weight of the dragster and driver. So that means that you are just going to use this again, right? So the net force is equal to mass times acceleration. This is the acceleration, so this equals the mass here, which is 914.9 kilograms, so we don't have to convert units, multiplied by 45.7 meters per second. And then this is going to be 41,823.7. 9 is asking how much force is applied to the driver in a relatively roundabout way. So just like the previous problem, it's the mass, which is 76.5 multiplied by this acceleration here, which is 45.7, which gets you 3,497.1. And finally, for question 12, so in this situation, if this is the car, let's say on wheels, it's going forward, so it would be accelerating forward. Even though this problem mentions the acceleration of gravity, it's not relevant in this situation because the car is not actually moving downwards, meaning it's not accelerating downwards. What this means is, just like the previous problem, you're going to first find the acceleration, so that's the speed it gets to, which is 42 meters per second over 5.8, which is 7.241 approximately. So that's 7.241 meters per second. And then again, the force is equal to the mass times the acceleration. So 7.241 times the mass, which is 70. So this equals 507. And this problem asks for kilonewtons, which means that you're actually going to put in 0.507.